Let's look at this example. We are given this simple circuit where we have an EMF, an internal resistance of 0.15 ohms, a load resistance of 8 ohms, and we are said that the voltage, the terminal voltage, is 12 volts. The question is, what is the current flowing in the circuit, and what is the EMF of the battery? Well, first of all, by looking at this circuit, let's find out what is the direction of the current. Now we know that the current is flowing from a higher potential to a lower potential. So this side of the battery is positive, so it's at a higher potential, which means that the current is flowing in a clockwise direction. So the current is going like that. So this is one thing. Well, now we can calculate the current, the magnitude of the current. We are given that the terminal voltage is 12 volts. Let's recall, what is terminal voltage? Well, a terminal voltage is the voltage across the two external terminals of a battery. So here is the battery. The battery is within this dashed box. So everything that's here is in the battery. And the delta VT is the potential difference between these 2 points. So let's say that this is VA and this is VB. Well, because we said that this side is at a higher potential, so we know that VB is bigger than VA. And this delta V terminal is equal to VB minus VA. Now, this potential difference between the points B and A is the same potential difference as between these 2 points. Why? Because there is no voltage drop across these 2 wires. They have no resistance. So from the Ohm's law, we can say that current is equal to the terminal voltage over the resistance. Terminal voltage is 12 volts. Resistance is 8 ohms. So the current is 1.5 amperes. So now we know the magnitudes of the current. The next question is, what is the EMF of the battery? Well, the EMF of the battery has to be bigger than the terminal voltage. Let's see by how much it's going to be bigger. It will be bigger than the terminal voltage by the amount of the voltage that is dropped across the internal resistance. So I times the internal resistance R. Terminal voltage is given, that's 12 volt, plus 1.5 times the internal resistance, that's 0.15. And so you get 12.2 volts. So this is the voltage of the EMF.